Good afternoon once again. I believe we can start. We are 8 minutes into the time. Please mute your microphones and let's have the class. So apologies for last week. We could not join the feed at the right time, and as such, our class, we couldn't have it. It is important to note also that as at last week, the course title and course code shared on the timetable with us did not match the course title and course codes on the Smart Campus. So many of us did not have the models. Thankfully, that has been rectified. Now we're supposed to do Unit 2, but unfortunately, we couldn't do Unit 1 last week. So the intention is to start the Unit 1 with you, make sure we are able to cover it, and then look into Unit 2 where we can end, so that at least you can make the good use of the time. So without much ado, I am Musa Isifu, your facilitator for the course, and it's going to be in a form of discussion where you are free to ask questions for better clarification if you have a challenge. And I pray that you also tolerate others who would like to ask questions for better clarification. It's a learning platform, and we have individual differences. And as such, let's tolerate each other so that we can have a healthy class and discussion. Thank you. So we start our discussion looking at the growth of science, Unit 1, Section 1, the growth of science. Now, under Unit 1, Section 1, as I mentioned, with the growth of science, we're going to discuss the following. These are the objectives we are to achieve when we are done perusing the session. It says by the end of this session, you should be able to, 1, explain the meaning of science, 2, distinguish between pure science and applied science, 3, explain the origin of scientific investigation, and last but not the least, mention some of the great scientists that lived between 6 and 300 BC. These and many more are the objectives we are to achieve when we are done with the session. Now, from the basic level, the word science is common or known to us. Today we are learning that the word science is from a Latin word which means to know. Which means to know. And that Latin word is scientia, to know. And that's to know, in its broadest context, means systematized knowledge in a field. Systematized knowledge in a field. It also means organization of objectively verifiable sense experience. organization of objectively verified sense experience. By that, what do we mean by objectively verifiable sense experience? As humans, we have 5 senses. The sense of touch, the sense of sight, the sense of hearing, sense of taste, and the sense of smell. Any knowledge that we acquire through the use of these senses, that can be verified, that can be proven, that can be confirmed, is science. So any experience through the sense of sight, touch, smell, taste, that can be verified is science. So by verify, we mean you can prove it. Sense of sight, they show you an object, you said, oh, the color is red. That's through your observation. You are using your sense of sight. The other person asks you, so it's color red, prove it, and you bring the object out. It's indeed color red. It has been verified. You are given something to taste. You taste it, you say, oh, it is sour. You are using your sense of taste. And then the organ you are using is the tongue. So if you claim it is sour in nature or in taste, and they give that same thing to another person to also taste it, it should be able to confirm that indeed it is sour. Now, let's note that science is the acquisition of knowledge through experimentation, investigation, observation. So any knowledge that we acquire through the process of experimentation, investigation, and observation or research is referred to as science. The sciences can be put into 2 groups. Which are they? Pure science, applied science. Science can be broken into 2 main groups: pure science and applied science. Now, when we talk pure science, what are we referring to? We are referring to the branch of science or the acquisition of knowledge through research. When you obtain knowledge through the process of researching, it is called pure science. Then we have applied science, which is the application of the knowledge obtained from pure science to solve problems. So the practical application of pure science is what we refer to as applied science. Then we have what we call technology. Please take note. For the branches, I said 2 main branches, pure and applied. But we also have something called technology, which is the use of scientific knowledge, ideas, skills, and tools to make products that makes the lives of human beings comfortable. When you use scientific knowledge, scientific skills, scientific tools, and equipment to make products which makes the lives of human beings comfortable, that is technology. And we have a lot of technological products in our daily lives. So currently we are having a session with the benefits of technology. So the computers we are using are product of technology. The smartphones we are using are product of technology. They make our lives comfortable. So today, you can place a call within a minute to a distant relative and have a conversation with the person. That is comfort for us. Today, through technology, we no more go to buy writing pad, envelope, stamp, and even travel to the post office to post letters. By the handset we are holding, either the computer or the laptop or the smartphone, you are able to send messages and get the response within seconds or minutes. But at first, what do you need to do when you want to write a letter to someone? You need a writing pad. You need an envelope. You need a stamp. Then you have to also walk to the post office, wherever it is, to post the letter. And formally, if you are posting a letter to someone within Ghana, it will take 1 week, 7 days before the letter gets to its destination. When it is going outside the country, you can imagine. But today, using technology through the phone or the computer or the internet, you are able to communicate with distant relatives at ease. Today, in our homes, our mothers and sisters are smiling. Why? Technology is making life easy and comfortable for them. How? There is blender, so they no more need a grinding stone, which formerly you visit any house, they have the grinding stone positioned somewhere. So if the woman or lady wants to do grinding, the pepper, the garden eggs, whatever she wants to grind, you walk to the grinding stone, go and kneel down, or you either squat, put your things there, and then be moving up and down, up and down. But today, what do we see? By the use of the blenders, by the click of a button, your materials are blended for you. Our mothers, our wives are happy in the house. Why? There is a washing machine. So she need not sit down and put all the clothes together, be doing manual washing. Jam everything into the machine. Click of a button. It is done. It is making life comfortable. We have refrigerators in our homes. We take chilled water, chilled drink, whatever. We can even store our products or our food. You watch television. That is a product of technology. That is making life comfortable. So you can sit in the comfort of your home and then watch any program in any part of the world. Whilst watching television, at first you did not have a remote to the TV. It was manual. When you are sitting apart from the TV and want to change channel, increase volume, put it on, put it off, you have to walk to the TV and press a button. Today we have remote, so you lie lazily anywhere, then be changing channels, increasing volume. That is technology which has made our lives comfortable. Now let's look at the origin of excuse me, origin of science. Now we are told that the effort to systematize knowledge can be traced to prehistoric times. That attempt to organize knowledge, it can be traced to prehistoric. By prehistoric, we mean the period before written records were done. And in what was the evidence to show? One, it was because people painted in the walls of caves. Through numerical records that were written or that were carved on bones and stones. Through artifacts. These are evidence of the attempt by human beings to systematize knowledge before the prehistoric time. Now, note that the oldest written record of proto-science, we are told, came from the Mesopotamia culture. The oldest written record of proto-science investigation came from the Mesopotamia culture. So what are some of the written things which were found on that record? One, list of astronomical observations, list of chemical substances, and list of disease symptoms, and then mathematical tables. These were all inscribed on cuneiform characters on clay. So there is evidence that our forefathers or the Stone Age man was recording data. And evidence of it, we are saying, is found in the Mesopotamian culture, which is the oldest written record. And some of the things which were found there are the list of astronomical observation, list of chemical substances, list of disease symptoms, and mathematical tables. Now, it is important also to mention that within that same period, paper documents were also discovered in the Nile Valley. Paper documents. So evidence of the existence of paper was found in the Nile Valley. Then what was contained on these papers which were found on the Nile Valley? One, there were information on treatment of wounds and diseases. There were information on the distribution of bread and wine. And there were also information on how to determine or calculate the volume of the portions of the pyramid. In present-day Egypt, we are told that the unit of length can be traced to the Egyptian prototype. And the calendar we are using today, which is common, is also indirect result of pre-Helsinki astronomical observation. That brings us to the end of Unit 1, Section 1, which details or which talks about science as a word coming from a Latin word meaning scientia, which also means to know. And we're saying that any knowledge that is gained through our senses that can be verified is science. And I mentioned that we have, as humans, we have 5 senses. Sense of taste, sense of smell, sense of sight, sense of hearing, and sense of smell. So any of these senses can be used to obtain knowledge. And provided that knowledge can be proven, it falls under science. And with the sciences, we said we have 2 main branches: pure science, applied science. Pure science, we said, the acquisition of knowledge through research. Applied science, practical application of the knowledge obtained from pure science. These are the 2 main branches of science. Then we touched on technology. We said the use of scientific ideas, skills, tools, and equipment to make products that makes human life comfortable. And if you cast your mind back to your homes, in our rooms, we have a lot of technological products which makes our lives comfortable. So some of us have home theaters which can help us either listen to music or dance to music or play music. You have refrigerators, you have air conditioners, you have fans, and what have you. These are all technological products which are making our lives comfortable. Then we discussed the origin of science, which we said attempt to systematize knowledge can be traced to prehistoric time. That is before the period before written records. And what evidence shows that? One, we said people painted on the walls of caves. Two, there were numerical records which were carved on bones and stones. Three, there were artifacts which were also containing some information. Then we noted that the oldest written record of proto-science investigation came from the Mesopotamia culture. What were some of those written records? One, list of astronomical observations. Two, list of chemical substances. Three, list of disease and symptoms. Four, mathematical tables, and so on and so forth. And we mentioned that during that same period, paper documents were discovered in the Nile Valley. And on that document, what were contained on the documents? One, information on the treatment of wounds and disease, information on the distribution of bread and beer, and information on how to find the volume of the pyramids, which are in Egypt. Any question up to this stage? If no question, you are to attempt the self-assessment question by yourself. Then let's look at Unit 1, Section 2, the rise of science theories. Now, scientific knowledge, we are told somewhere, okay, let me take you through the objectives of the session. It said by the end of this session, you should be able to distinguish between Thales' concept of the Earth and Pythagoras' concept of the Earth. Explain how philosophy of Plato and Aristotle were developed. And last but not the least, explain the difference between Aristotle's concept of planetary system and Ptolemy's concept of planetary system. These are the objectives we need to achieve at the end of the session. Now, we'll look at scientific knowledge in Egypt and Mesopotamia. Now, I think from the previous lesson, we observed that scientific knowledge started somewhere in the Mesopotamia, which is current-day Iraq, and it came down to Egypt, which is in Africa. Now, we are told that the scientific knowledge in Egypt and Mesopotamia were mainly of the practical form or nature. And there was little rational organization of the knowledge. Among those who attempted to rationally organize the knowledge were the Greek philosophers. So one of the philosophers was called Thales. Thales in 16th century BC. He postulated that the Earth was a flat disk floating on the surface of water. Please take note. According to the authority called Thales, Earth is a flat disk floating on a universal element, which is water. Then there was a mathematician and a philosopher called Pythagoras, who came after Thales and established a movement in which mathematics became a discipline very vital for the study of scientific investigation. According to Pythagoras, or the Pythagorean scholars, the Earth is spherical and it moves in a circular orbit about a central fire. So you take note, there are two schools of thought here who are providing details as to what the Earth is or looks like. Thales is telling us that the Earth is a flat disk floating on a universal element, water. Then another philosopher called Pythagoras, he was instrumental in getting mathematics to become a discipline vital in the study of the science. And he and his group were also of the view that the Earth is spherical in nature and it moves in a circular orbit about a central fire. Now, during that time, the Babylonians and the natural philosophers like the Pythagorean put their heads together and ensured that mathematical science produces the synthesis of philosophy of Plato and Aristotle. Plato and Aristotle are two great men that we deal with in our sciences. Now, these two great men had their schools of thought. The Academy of Plato, they believe in the deductive reasoning and mathematical representation of scientific knowledge. That is the Academy of Plato. Then the Lyceum of Aristotle also believed in inductive reasoning and qualitative description in the field of science. Now, the interplay between these two schools of thought or approaches to science has led to the advance in logic. Then we have the Hellenistic age, the 4th to 1st century BC. There was a man called Alexander the Great. He was a mathematician, an astronomer, and a geographer. There was another learned person called Eratosthenes. He made some accurate measurements of the Earth. He was also an astronomer.
Sister, wait here. Your wish is my command.
Please mute your mic. Please mute your microphone.
I feel that now I feel hope. And you said,
Now, the mathematician and inventor Archimedes laid the foundation of mechanics and hydrostatics. We have another great philosopher and scientist That's Theophrastus. He became the founder of botany. The founder of botany is called Theophrastus.
301.
Then we have another astronomer called Hipparchus. He developed the trigonometry.
I mean, 2000.
So please take note when you are reading. Look at the philosophers and their contribution to science. This brings us to the end of Unit 1, Section 2. Any question, please?
300.
In the absence of a question, we'll discuss Unit 2, Section 3. Unit 2, Section 3.
It's a nice to say, no problem. You say what boy, but
Unit 2, Section 3 talks about the 6 leading cultures in science. So in the olden days, there were 6 leading cultures who made a lot of contribution towards the field of science.
The
6 leading cultures
I know how to handle them.
Albert, please mute your mic. Albert, please mute your mic. Is anyone close to Albert? Please tell him to mute his microphone. Albert Avoka. Okay. So let's look at the 6 leading cultures in the sciences. Now, those cultures which made some contribution towards the development of science are the Latin West, the Greek East, the Chinese, the East Indian, and the Arabic. These 6 cultures played a role in the advancement of science. Now, I pray that I would like you to take your time, read it thoroughly, and appreciate the role of each of the cultures, the 6 leading cultures, towards the advancement of science then and today. Now, when you go through it well, you observe that the Chinese played a pivotal role in the advancement of science. How, in what way did they do that? Now, we are told that in China, mathematics reached its peak in the 13th century with the development of a way. They found a way in solving algebraic equation by using metrics and by using arithmetic triangles. The Chinese people impacted Europe in several practical ways. Some of the ways by which the Chinese impacted the Europeans include the manufacturing of paper. They manufactured gunpowder. They brought about the innovation in what? Printing, and also the mariners' campus, the campus that people who go to sea uses. And in India, their main contribution towards sciences was the formulation of the Hindu-Arabic numerals. That is the role that the Indians play in the advancement of science. And those Hindu-Arabic numerals are still in use today. And they also played a role in conversion of trigonometry into modern form. So today, the form in which trigonometry exists, that we've all solved, was through the effort of the Indians. It is important to also note that Baghdad, which is in Iraq, that is the Tigris River, became the center of translation of scientific work. And in the 12th century, this learning was transmitted to Europe through Spain. So Baghdad, which is in Iraq, along the Tigris River, was the center of transmitting scientific knowledge and the work from that place to Europe. And it went through Spain, Sicily, and Byzantium. There were some controversies on the scientific method. Now, we all talk about the scientific method, which we are told as the approach by which scientists answer or solve problems. So you take your time to read that carefully. Also pay attention to some of the scientific publications. Now, it is important to mention that whilst there was effort to ensure the growth of science, the Black Death and the 100-Year War, Black Death, there was a disease in Europe, which is termed the Black Death, and the wars which human beings fought disrupted scientific progress for more than a century. That is over 100 years. There were some diseases and human beings were fighting wars that affected the progress in scientific work. So please, you take notes when you are reading. That also brings us to the end of Unit 1, Section 3. Next, we'll look at Unit 1, Section 4. Unit 1, Section 4, which talks about modern science. And the objectives for the section are explaining the contribution of Galileo leading to the discovery of scientific instruments such as telescope, microscope, and thermometer. Mention 3 other scientists and scientific instruments they developed. And last but not the least, mention the names of the scientists whose work provided the background for materialistic science of the 18th century. Now, there was a great scientist called Galileo. He was a scholar and an artisan. So he combined these two roles in helping advance the cause of science. Now, he came up with the use of the telescope, the use of the microscope, and the use of the thermometer. These were instruments that were used by the scientist called Galileo to get better understanding of issues. Now, the telescope is a device that is used to observe distance objects. So if you want to study the stars, as in astronomy, you are on Mother Earth, you need a telescope to be able to have a clear view of the stars in the sky. Then we have the microscope, which we are all familiar with as science students, found in the lab. Equally, when you go to the hospital, you find microscope there in their lab. They use it in analyzing samples. Then the thermometer, which is a device that is used to determine the temperature of a body. By temperature, we mean the degree of hotness or coldness of a body. Simply put, how hot or cold a body is. So growing up, when you were not feeling well, mom or dad will use the back of the palm to feel your forehead in attempt to tell how hot or cold you are, which can be a symptom of a certain disease. By using that, yes, they can tell you are hot or you are cold, but cannot give you accurate reading. So currently we have a device called a thermometer that you can use to give accurate reading of body temperature, i.e. how hot or cold a body is. So these were the instruments that Galileo used in helping the advancement of scientific knowledge: telescope, microscope, and thermometer. Let's take notes. Then, later in that century, several experiments were conducted by use of the barometer, and that was used by the Italian mathematician and physicist Evangelista. He used the barometer. Then an English scientist also used the pendulum clock. So please, you take notes, the scientists and the instruments each of them use in advancing the course of science. Then let's look at some scientific discoveries. Now, many scientists helped in making discoveries. Among these scientists was Sir Isaac Newton. Sir Isaac Newton. Other scientists. Now, please note that Sir Isaac Newton played a role in mathematical principle of natural philosophy. He did the invention of calculus which was done by Newton and German philosopher Gottfried Wilhelm. Other scientists like René Descartes, he provided background to the materialistic science of the 18th century. René Descartes provided the background for the materialistic science of the 18th century. And in that, life processes were explained on physiochemical basis. Life processes were on physiochemical basis. So basically, that is what we have for the section 4 of unit 1. Once again, you need to sit back at home and then go through it. You find scientists like Charles Darwin and others, John Dalton, Michael Faraday. Please take note of their contribution towards the development of science in our societies. That brings us to the end of Unit 1, Section 4. Any question, please? Any question? In the absence of a question, we proceed to Unit 1, Section 5. Unit 1, Section 5. And under Unit 1, Section 5, we're going to look at scientific communication. Scientific communication. Under that, these are the objectives for the lesson. We are to mention which institutions in medieval times were responsible for preserving scientific work and fostering scientific activity. Identify some of the old scientific societies responsible for promoting the study of mathematical physics and natural science. Identify some of the modern international organizations responsible for communicating scientific ideas among scientists. Now, it is an established fact that scientific knowledge is transmitted through written documents. Scientific knowledge is transmitted through written documents. So as we have this class, you observe that the document we are using, be it the hard copy of the model we have, or the soft copy, provides us with knowledge which is in a written form. So we are told that throughout history, scientific knowledge has been transmitted chiefly through written documents, some of which are more than 4,000 years old. So the science we pursue, the scientists who discovered the knowledge or who made so propounded the laws and theories were not Ghanaians. But because whatever information they had, they were able to write it down. That knowledge is able to move to every corner of the world. So during the olden days, there were people who tried putting these documents together to preserve the knowledge. The Greek or the Greece people attempted it. The Arabs also did same. Some universities and schools also did same, and so on and so forth. Now, since the Renaissance, the work of transmitting scientific knowledge has been taken on by some oldest societies such as the Accademia del Liceo. This academy is the academy to which Galileo belonged, and we are told it was established in 1603 to promote the study of mathematics, physical and natural science. Later within the century, another school was established. That is the Royal Society of London, 1662, which also helped in transmitting and preserving scientific knowledge. Then under scientific, so check, you have several of the academies which were responsible. So please, in reading, I need you to pay attention to those academies and the role they play, either in preserving or transmitting scientific knowledge. Then let's look at the scientific communication. So at the higher level, when you publish, when you write a piece, a paper, there is the need for you to publish it. And there are reputed publishing societies or organizations which you have to send your document to for them to go through it and approve it for either referencing or for use. Among them is the American Academy of Art and Science. So please take note when you are reading and know what they do. Then you have Association of Francis Puer. That's surely a French thing. So please, when you are reading, you take note of those academies which aid in the communication of scientific knowledge in America and Britain. Equally, we have some international organizations which are also facilitating the publication and communication of scientific knowledge. We have the International Bureau of Weight and Mass, the Union. There are several of them listed in the literature. So I pray you take your time when reading to ensure that you grasp the concept of all that we are talking about. Quickly, I'll touch on just some few parts of Unit 1, Section 6, so that we can move to Unit 1, Section 2, which is what we are supposed to do for the week. Under Unit 1, Section 6, it is looking at the field of sciences. Field of sciences. Unit 1, Section 2. Field of sciences. Objectives. Distinguish field of science as proposed by Pythagoras and Aristotle. Mention the pure science. Explain the importance of interrelationship among the sciences. And last but not the least, distinguish between pure science and applied science. And also name 4 examples of applied science. These are the objectives for the session. Any question, ladies and gentlemen, before we look at that last session? Okay. Silence means we are good. But if you so have a question, you can show by hand for us to give you the opportunity to ask. Now, with the field of sciences, there were schools of thought or scholars who identify certain fields that are associated with the sciences. For example, the Pythagorean scholars, they distinguish 4 fields of science. And these are arithmetic, geometry, music, and astronomy. These are the 4 fields of science which the Pythagorean outlined. Now, by the time of one great man called Aristotle, other fields of science also become recognized. So the Pythagorean identified 4 fields.
Thank you, Mama.
By the time of Aristotle, other fields of science were added, which included mechanics, optics, physics, meteorology, zoology, and botany. Now, when we talk botany, it's the study of plants. Zoology is the study of animals. Meteorology is the study of the day-to-day happening in the atmosphere. Now, when we talk the day-to-day happening in the atmosphere, then basically we are talking of the weather. And those happenings, day-to-day happenings in the atmosphere include sunshine, the rain, cloud, mist, fog, and so on and so forth. We have physics, optics, mechanics, and so on. Now, it is important to mention that chemistry was outside the mainstream of science. And it was during the time of Robert Boyle in the 17th century where geometry achieved the status of science. Then the study of heat, magnetism, and electricity also became part of physics. Then pure mathematics was also recognized to differ from other sciences, that is, in the logic of relation and what have you. Pure science, we've already touched on it. We said the practical application of knowledge obtained, this pure natural science, which we are told is divided into 2 classes, the physical science and biological science. Pure natural science has 2 main groupings, physical science and the biological or life science. Principal branch among these one are physics, astronomy, chemistry, and geology. The main biological sciences are botany and zoology. Please, let's take a look. Now, the physical sciences can also be subdivided into fields such as mechanics, cosmology, physical chemistry, meteorology, psychology, and biology, and whatever. Now, all these fields have some interrelationship among themselves. The interrelationship among these fields help in the betterment and enhancement of the knowledge of science, or in the production of better scientific knowledge. Now let's look at the interrelationship between biology and chemistry. So we have students who specialize in a course called biochemistry. So it talks about the relationship between biologists and chemists. So it said biochemists, for example, synthesize deoxyribonucleic acid, DNA. Then the cooperation of biologists with physics also led to the invention of the electron microscope, which we use in the lab and are used in the hospital or research centers for further studies to appreciate some bacteria, viruses, and even gene mutation.
Fiore. Huh?
Then let's look at the applied science. What we looked was applied natural science. Now looking at the applied science, which is the practical application of knowledge obtained through research or pure science. Fields of applied science include aeronautics, electronics, engineering, and metallurgy. We have bioengineering and what have you. Please take your time and peruse the document well. Any question up to this stage before we start something on our section 2? Any question, ladies and gentlemen? Any question, please? Please, any question? Vivian. Cecily. Augustine, any questions so far? Rosemary, any question?
No, sir.
Albert?
No, sir, boss.
Albert, please, I need you mute your microphone. Aisha Edu. Okay. In the absence of a question, let's proceed to Unit 2, Section 1. Unit 2, Section 1. So under Unit 2, Section 1, we're looking at the nature of science and science education. The objectives for the section are influence of science. Explain how science has influenced society. Explain the phrase way of knowing science. Distinguish between natural history and science. Explain the goal of science teaching. And last but not the least, explain some of the principles underlying science teaching. So, under influence of science, it is true that science have had some influence on humankind or our societies, both positive and negative. It has influenced the affairs of humankind profoundly. Now, for the past century, development, we've seen a lot of changes in our lives, which are as a result of science. What are some of the ways by which science has influenced our lives? We are told that the practical fruit of science, such as harbors, computers, cars, mobile phones, space flights, aeroplanes, and many more, have some positive influence on us. Science has become something such that nations or countries now see science as an instrument for national growth as well as survival. Countries or nations, or call them governments, have come to the realization that science is an instrument for national growth and survival. The same science provides human beings with some material convenience. So, what are some of these material convenience? The cell phone is portable. We carry it everywhere. We use it to chat. You can use it to make calls. You can use it to take photographs. You can use it to take videos. You can use it to record your song or whatever you want to do. When was the last time you called a photographer to your house to come and take a photograph of you? Now, with the help of this smartphone, you take your selfie, or even after dressing up, you can call your child or somebody somewhere that will take a shot of me, and that will be taken. If you want that picture printed out, it can be done. So science, it provides us with material comfort. Nations or governments see science as an instrument for national growth and survival. Science has also helped in the prolongation of human life. It has, call it, increased our lifespan. Now, there are hospitals around which are well equipped to attend to us when we are sick and in emergencies. We now have better medications. So many of us are on medication, which if we are not getting the medication, that may fast track our process to the next world, or make our ancestors welcome us back home. But because of good and better medications around, we are still alive. So these are some of the ways by which, call them positive or advantages of science. Now, due to these positives, nations, countries, or societies are now putting in efforts to either increase or improve scientific literacy among its citizenry. That is, students and the general public. Now, this effort that nations or countries are taking to improve scientific literacy among its populace comes in the form of one, now there are courses in our senior high school, even in the primary school and at the universities, which students study to help them acquire knowledge in the sciences. Currently, the school curriculums have also been tweaked or changed to reflect the happenings, the current happenings in our societies or the world. So he said we are now in the technological age. So in Ghana, there is an effort to drive home STEM education: science, technology, engineering, mathematics. And that is being done from the lower, upper, senior high school, and even at the university. That is important for us. That brings us to the end of Unit 2, Section 1. Unit 2, Section 1. Now we look at Unit 2, Section 2. Unit 2, Section 2. It said science as a way of knowing. Objectives for the section: explain the phrase science is a way of knowing. B, explain what is meant by the product of the scientific enterprise. And last but not the least, explain the methods of science. Now let's look at science as a way of knowing. So when we say science as a way of knowing, what do we mean? We're saying that science is an ongoing process that focuses on developing and organizing knowledge. It's an ongoing process which pays attention to the developing and organizing knowledge. Now, when you talk science as a way of knowing, it also suggests that science is not the way of knowing. Now, the word way, it can be interpreted to mean what? Course of action, habit of mind, set of procedures, inclination to certain behaviors. So science, a way of knowing, means literally that it is through science that we get to understand and appreciate the world. So you may be asked to explain what is meant by science as a way of knowing. And we are saying it means science is an ongoing process that focuses on developing and organizing knowledge. Now let's look at the product of scientific enterprise, which is a body of knowledge which consists of description and interpretation of natural world on which the scientific community agree. The product of scientific enterprise is made up of description and interpretation of the natural world on which the scientific community agrees. And we say that the tentative nature of science, when we say scientific knowledge is tentative, it means that scientific knowledge is subject to change. Scientific knowledge is not stable. Scientific knowledge is not rigid. Today, scientific knowledge can tell you 1 + 1 is 2. Tomorrow, based on better observation, experimentation, and equipment, scientific knowledge can now tell you 1 + 1 is 3. Let's take note. Then let's look at methods of science. Methods of science. So we were told there is a procedure or protocol by which scientists solve problems, which we call it scientific method. Suggesting that for scientists to come out with any knowledge or to solve a problem, they need to observe certain protocols. Better still, follow a systematic, call it step-by-step approach in discovering the knowledge. Some of the methods involved in the scientific or used by scientists include observation, measurement, hypothesis formulation and testing, data collection, experimentation and investigation, prediction, and what have you. So for a scientist to undertake any project or work, he or she needs to follow the methods of science. You need to do measurements. You need to formulate hypotheses. You need to collect data. You need to analyze data. You need to make predictions, and so on and so forth. All these leads you to a better understanding of an issue or finding solution to a problem. In that note, we end Unit 2, Section 2. Let's look at Unit 2, Section 3. And it talks about the nature of science and science education. Nature of science and science education. And the objectives shared are: explain how scientists share common view about the world. Explain why any scientific knowledge is subject to change. Explain the benefit of process of science. And last but not the least, explain at least 2 factors to illustrate the nature of scientific knowledge. Scientific knowledge is based on assumption. scientific knowledge is based on assumption. We are told now, scientists hold a common view, and that view is shared by scientists in the world. Scientists believe that, one, the world is knowable and understandable. The world is knowable and understandable. Meaning that for a scientist, there is nothing impossible to be done. To the scientist, if you said to yourself that you want to do something, you can do it. To the scientist, if you sit up and tell yourself, I need to understand this, you will understand it. With determination, hard work, there is nothing that cannot be accomplished. So that is what scientists, one of the beliefs of science. Now, they also believe that the universe is not capricious. They believe that patterns in the universe reflect an underlying order in the universe. So the patterns we see in the world, they were not just by accident. They reflect an underlying order. Scientists believe that through systematic study, application of instruments, and the intellect, more discoveries can be made about the world. Through systematic studies, application of instruments, and the use of the intellect, that is the mind or the brain, we can make more discoveries about the world. They also believe that the universe is a single system which contains numerous subsystems. So when you take the universe, scientists see it as a whole. And in that whole, you can put it into pieces to get the various components or departments of the universe. One of the assumptions of scientists is also that knowledge gained from studying one part of the universe can be applied to other parts of the universe. And they also say that the law of gravity on Earth is the same for other planets. Now, note, scientific knowledge, we're saying that is both tentative and stable. Scientific knowledge is tentative and stable. Knowledge, we are told, is produced by the process of science. However, the knowledge is subject to change. Why is it subject to change? Because of new observation, experimentation, which is producing knowledge that challenges existing explanation. So note earlier I said, today science can tell you that 1 + 1 is 2. Tomorrow, based on better observation, experimentation, the use of the intellect and better instrumentation, that knowledge can change. So therefore, knowledge of science is not absolute. Neither is it complete. We keep on adding to it. And it is important to also note that science does not prove anything once and for all. And the knowledge we acquire from science helps scientists to make predictions based on probability, and they give temporal explanation. Now, yes, we said scientific knowledge is tentative. It is important to add that it is also stable. It is stable. Now, the processes of science lead to the modification of ideas or reconstruction of ideas rather than outright rejection. The processes of science, they lead to the modification and reconstruction of ideas. Please, let's take note. Scientific knowledge is for public consumption, meaning that as a scientist, when you discover knowledge, that knowledge is not meant for your private use. Neither can such knowledge be classified as a family property. That knowledge is for public consumption. Reason why, when scientists do their work, they publish it. By publishing it, they make it available to everybody and to anyone who so wish to read and understand what has been discovered or found. Scientific knowledge is empirical and replicable. So knowledge obtained from science is based on observation and experimentation. When we say empirical, evidence that can withstand the test of time, evidence that can be proven. And we're saying it is replicable. You can reproduce it. So when party A sits somewhere and do something, if he or she put down the protocol for doing it, send it to you at location C, and you follow that protocol with the same ingredients, you should arrive at the final answer he or she had at a different location. So we say it is empirical and replicable. Scientific knowledge, we are told, the last one is scientific knowledge is in continuous state of change. So day in, day out, new things are being found and added to existing knowledge. Reason why the knowledge is what? Tentative and stable. That brings us to the end of Unit 2, Section 3. Any question, ladies and gentlemen? Any question? Ladies and gentlemen, any question? You have 5 minutes to ask questions for clarification. I'm giving you 5 minutes to ask questions. Does the silence means we should proceed? Rose Kati, any question? Hafsa Mustafa.
No question, sir.
Augustine Techi. Albert Avoka.
No question, sir, please.
Aisha Edu. Aisha Edu, any question?
No question, please.
Okay.
Yes.
So in the absence of a question, I guess we are good to look at Unit 2, Section 4, which deals with science and philosophy. And in this section, we are to explain the Platonism and Aristotle deductive models. Platonism and Aristotle deductive models. The objectives for the sections are: 1, explain the philosophy of science based on the deductive method of Plato and Aristotle. Explain the philosophy of science based on empirical method of Francis Bacon and René Descartes. And lastly, differentiate between Bacon's method of discovering the truth and Descartes' method of solution to problem. Now, the 16th and 17th centuries, we are told, gave birth to the empirical science. Prior to this, the philosophy of Platonism and Aristotle deductive method and Aristotle deductive method were leading. Now, the search for the truth was centered in the analysis of universal ideas. So within the 16th and 17th centuries, the quest to find the truth was centered on the analysis of universal ideas. And there was little interest in verification through experiment. So proud to this. For us to tell the truth, for us to find knowledge, said it was based on the analysis of universal ideas. And there was no interest in trying to use verification or to do verification through experiment in order to confirm what is being talked about. Now, an authority, Bacon, and the Scottish empirical method. Now, these two, Francis Bacon and René Descartes, they both developed empirical method of generating knowledge. They were of the view that it wasn't necessary for scientists to appeal to authority. Reason being that each person is capable of finding the truth, either through careful observation or through the power of the intellect. So as you said, we are able to find the truth through careful observation and the use of our brain or the mind. That is what these two gentlemen propounded, that you are capable of finding the truth either through careful observation or through the use of the brain. They encourage us, Bacon and Descartes, they encourage individuals to think for themselves and describe the method for discovering the truth. So you have what it takes to think for yourself. You have what it takes to discover knowledge, according to these two authorities, through careful observation and the power of the intellect. Then we have Descartes' rational method. He also said that, according to Descartes, the foundation of knowledge rested on clear and distinct ideas. The foundation of knowledge rests on clear and distinct ideas. According to him, the method for arriving at these ideas are stated below. What are they? Please pay attention to this one. It says, accept nothing as the truth, which is not clearly recognized to be true. Accept nothing as the truth, which is not clearly recognized to be true. So the fact that I came to you and told you something does not mean it is the truth. Don't swallow it hook, line, and sinker. You have what it takes to do further checks to confirm whether indeed I'm being truthful. Avoid prejudice in judgment and accept nothing more than it is presented to the mind. Avoid prejudice and judgment. So they come to, oh, this one, I know he will do it. Meanwhile, you are not armed with the facts. You don't even know what happened. But just because they mention somebody's name, you see me looking like something or whatever, you will have your perception about me. They say, oh, this guy, he has done it. Don't be prejudiced or prejudicial, and don't be too quick to judge. Now, you need to divide the problem into parts for further resolution. So when you have a problem, you break the problem into parts, i.e. pieces. That gives you the opportunity to better understand each of the pieces that makes the whole or the problem. Then it says study the objects that are simplest and easiest to understand. So when you break it into pieces or into parts, look at those that are easier and simpler to understand. It's just like you sitting in the exams going to take a paper. They put the paper before you. The paper is a whole. You are asked to answer maybe 2 or 3 questions. It is important that you take your time to read the question. In doing so, you are able to identify the questions which will be easier for you to respond to, and those that would need you to sit down and think more. And when you identify those questions that you want to answer, what do you do next? You start from the easiest and simplest one. Very quickly. Finish with those ones before you go to tackle those ones that will give you headache. I believe that is okay. So that also brings us to the end of another session. Any question, ladies and gentlemen? Any question, please? Okay. Silence means we are good, and I'm happy you are good. I only pray that after these interactions, you make time to read the document carefully, because you need to read in between the lines to prepare yourself adequately for the quizzes and also for the presentation and your end of semester exams. We are just about 10 minutes to the end of our session, and we have 2 sessions left. That is section 5 and 6. I'll pray you make time to read them. Today, we were able to cover from Unit 1, Section 1, up to Unit 2, Section 4. Now, make time to read. If you have any question or any challenge on what have been discussed, you can send a message or post it on the platform. Then we all collectively see how best we can help you answer that. If you come across a past question that you have challenged and respond, but you need to respond first. If you have the question, for me or for others to assist you, share your solution with us. Then we can also have a bite at it. In that way, we'll all be benefiting from the discussion. But don't just pick the question and come and put it there and ask for answers. We need to know what your take about it before we also make our contribution. So, God willing, we'll end our session today. Once again, if you have a question, do not hesitate to share. if there are no questions for this time, the next 7 minutes is for you to ask questions. If you don't have questions to ask, then I strongly believe we can say good evening and wish ourselves the best for the rest of the day.
Let's say.
Please go ahead.
Please say, the time. It still clashes with one of our courses. The last time I remember I made mention of it. Even right now that I've gotten to know that we are having classes that I just joined late.
Beatrice, right?
Yes, please.
Which course does it crash with?
Calculus.
Calculus.
Yes, sir.
Then what do is that share it on your common platform. The code refs from codes are on the platform. So put it
Okay.
there, informing them that this time crashes with this, and as they will resolve it. But I'll also take it on. You said calculus, right?
Okay, sir.
Okay, thank you.
Okay, sir.
You are welcome. You are welcome, Beatrice.
Thank you.
Okay. In the absence of a question, let's end today's session here. We meet another time. Thank you for your time.
one. Hello.